All right, so the domain of the arc and inverse sine and arc and inverse cosine is the same. So what you go in, do you have extra papers to pass by? All right, so what goes in has to be a number between -1 and 1 because that's what you get when you take the sine and cosine. And then what comes out is going to be an angle that's either in the first quadrant or the fourth quadrant. Now you can get, an angle in any quadrant, but the official angle you get for inverse sine for inverse sine is in the first or the fourth quadrant, right? For cosine, the official angle you get for inverse cosine is going to be the first or second quadrant. And then tangent, we can put anything into the inverse tangent because when you take the tangent of an angle, you can get any number. But what you get out of the inverse tangent has to be an angle in the first or fourth quadrant. Now, we're just going to use that here at the beginning when we're drawing some triangles. All right, and then here are the graphs of them. These two do not keep going. This is an end point at -1, -pi/2, and this is an end point also. Now this arctangent does keep going to the left and to the right, but it stays in between pi/2 and -pi/2. I don't think that's going to come up very much, the graphs. Okay, so what we are going to do with this for our example is find the exact value using a right triangle sketch. Okay, so this is gonna look weird, and when you first see it, it's gonna feel kind of confusing, but I think you're gonna be fine. So for A, we have the sine of the arc cosine of 2/3. So if you saw that on the ACT or on the challenge exam, you'll probably be like, I have no idea what is going on. But what does the arc cosine give you? It's the inverse cosine, but it gives you an angle. So what we want to do is draw an angle that has a cosine of 2/3. So this part inside here is just the angle. Now, since 2/3 is positive, we are going to draw this in quadrant 1. So this is what we're looking for, or this is what arc cosine is. This angle theta that has a cosine of 2/3. So if there's a cosine of 2/3, what sides do we know? The adjacent and the hypotenuse. Go ahead. Now, can we find the third side? Definitely. So the third side, we're just going to call it B. So since we have a hypotenuse, we're going to subtract with the Pythagorean theorem. Okay, so 9 minus 4 is 5. So this side is going to be the square root of 5. Now we aren't finished, but we have what we need to get this answer. So now we're just going to find the sine of theta. So this right here is just telling us to find this theta. Now to finish the problem, we use the outside. So what is the sine of theta? Thank you. The square root of 5/3. So we just use this right triangle. We do the opposite over the hypotenuse, and we're done. So that's a weird, it's just weird notation to tell you to do something that's not that hard. We've done tons of these triangles before. It's just a little different. Okay, let's look at another one. For B, we have the cosine of the inverse tangent of -2. I read that kind of weird. Okay, so inverse tangent of -2 just means find the angle that has a tangent that's -2. Now, there are two quadrants where tangent is negative, but for the arc tangent function, which is what we're working with, the only two quadrants we're going to use are the first and the fourth. So which one will we use for a negative? The fourth. So we'll just draw our triangle in quadrant 4. Theta is what we're finding when we do the inverse tangent. Alright, so we want to label this in a way that the tangent of this angle is -2. So what should the opposite be? 2. And the adjacent? 1. Now this is not the only triangle we could draw. We could do 4 and 2, 6 and 3, anything that we divide opposite by adjacent, we get 2. Alright, you guys find the hypotenuse for me, please. Alright, did y'all get square root of 5? Okay. And we want to find the cosine of theta now. Alright, so first, in quadrant 4, is cosine positive or negative? Positive. So I'm asking you to remember a lot of things from those packets that we worked with. The cosine's positive in quadrant 4. So we're going to do the adjacent over the hypotenuse. And then we all know we don't leave the radical in the denominator. So square root of 5 over 5. Okay, we're going to do one more on the back with numbers, and then we're going to start doing some with variables. So for C, if you have room on the front, you can keep going in front. But we have the cosecant of the inverse cosine of negative square root of 3 over 2. Okay. So this time the inverse, we're doing the inverse cosine of a negative. So I'm going to flip it over real quick. So for the inverse cosine, we have to use angles either in quadrant 1 or quadrant 2. Alright, so for a negative, that's going to be quadrant 2. Alright, you guys label the sides for me, please. And what y'all get for this leg? one. This is actually a special right triangle. Okay, so we want to find the cosecant of theta. So cosecant is the reciprocal of sine. Is sine positive or negative in quadrant 2? Positive. So we're going to have a positive. All right, so sine is the opposite over the hypotenuse. So cosecant will do the hypotenuse over the opposite. So that's just going to be 2. All right, any questions on those before we move on to some that are a little weird because they're going to have x's as your side lengths, and so it makes it a little more challenging. Okay, let's look at D. We're going to have the cosine of the arc tangent of 2x. Now these ones that involve x, we just go ahead and draw them in quadrant 1. Or actually, it doesn't even have to be in a quadrant. We could just draw a right triangle. Doesn't matter. Okay, so we know the tangent of this angle is 2x. So when I divide the opposite by the adjacent, I get 2x. So what could my opposite be? Okay, if this was 4x, then what would this be? 2. We could do that. Do y'all want to do that? There's one that's more simplified that we could do. That will 100% work. You'll just, when you do your next fraction, you'd have to reduce. All right, so y'all, using these as your sides, find your hypotenuse, please. So it looks like our hypotenuse is going to be the square root of 4x squared plus 1. All right, so now we're going to find the cosine of theta. All right, so we're just going to do the adjacent, bless you, over the opposite. Now, if this was an ACT question, I think they would probably leave it like this. I'm not 100% sure, but I think on the challenge exam, they would expect you to simplify this. This really isn't different than normal, like when we had 1 over the square root of 5. So it's the same thing. So that's just going to simplify to the square root of 4x squared plus 1 over regular, just 4x squared plus 1. You want to try one of these on your own? Okay, you're going to anyway, it's fine. All right, so for E, we're going to do the sine of the inverse cosine of x. And if you don't want to draw it in the quadrant, you can just draw a right triangle if you want to. So once we get our sides labeled on our triangle, we're going to find the sine of theta. So what do you guys think? Square root of 1 minus x squared over 1, which we don't need to write the 1. All right, any questions? All right, there is a whole lot more to learn about inverse trig functions. We just don't have the time to get too deep into it, but I think you'll be fine with what we're doing. So your assignment today is out of the book, page 327. I want you to do 54 through 74 even. Do you guys want to say anything to all the people in the DECA trip? Livy, hope you're having fun. The rest of us are super jealous because it's going to rain here the whole time you're gone.